Let's learn about parsing numbers in Java and why we have to do it in the first place. For the purposes of this demo, I am using an online Java compiler and runtime simulator. This allows me to focus purely on the clean, clear, crisp Java and not have to worry about the noise of an IDE or of other platform overlays like Android. This is just pure Java. We're going to compile it, execute it, see console output. Now, first let's talk about how we parse or what parsing is. First, parsing is when we take a string and pull from it numeric data. In fact, I might even say we pull from it meaningful numeric data. And this is what it looks like. Imagine for a moment that you have a string of user input where the user has given you something like the string 10. Let's say that you want to use that number in some mathematical equation. Hypothetically, let's just say that you want to square the value and report that back to the user. So how would we do that? Well, we'd probably, just for safety's sake, have a long called product, and then that product would be the result of our user's input times itself. And therefore we have squared the value, and we should, in this case, get 100. Then, when I go to report that back to the user with a print line, I can simply just slide product in there, right? If I hit run, we're going to have a problem. Here it says there's a bad operand for this type of operator. Because right now I've got two strings. I don't have two numbers, I have two strings. Now you and I see this and we know that it's the number 10, but the computer does not. Which means that there's an extra step. We must say that the num, this int, is going to be the parsed value of the user's input. How do we parse? First, we call this class called integer. This is the class representation of the primitive int. So int is a value type, it's a primitive, it's the smallest building block of its kind. Integer is the more complex class version, which means that there's data about the int and there are functions the int can do when we use it as an integer, as opposed to just a regular int. In other words, int is a really tiny basic building block, integer is a more complex building block, but they can represent the same value. That integer class, if we follow it with a dot, will allow us to call parseInt, a function that takes in a string, like user input, and then will return to us its literal int value. So the string 10 is going to go in to this function. This function will then return the value 10 as if we had written 10 with a semicolon, right? So this function is effectively the same as what you see here to the left. The only difference is the user can give us any number they want, and this function will parse that value into its int form. All right, let's go back to what we had before. So now I've got a number that is the numeric representation of this string's meaning. So we call long product equals not user input anymore, but just num. That's the parsed number from the user input. And then we send product to print line. I click run. And this time, everything works just fine. The math is correct. Everything is great. This is how you parse. Now the question becomes, why do we parse? All right, let me show you the truth about strings for a second. You see, strings are really just a collection of chars, or characters, right? Chars is short for characters. Strings are really just a collection of chars. It's also important to note that chars are really just numbers under the hood. So a string is a collection of chars, and chars are really just numbers. But they're not the numbers you think they are. For example, if I declare a char, and let's just call this symbol, for example, and I set it equal to the char literal 1, this char is now the symbol that you and I call 1. And if you and I look at this, we think of this as the number 1. Let me make an int And let's call this the symbol value. And let's set that equal to our symbol, but we're going to take our symbol and cast it to an int. Remember that casting comes from the term where you build a mold and then you pour hot wax or metal into this mold so that that liquid can take shape. Casting takes data of one type and pours it into the mold of the other type. So we're going to take this char data and we're going to cast it as an int. Watch what happens. I'm going to print out the symbol itself using some concatenation here. And I'm going to print out the number as well, the symbol value, using some concatenation here. Watch what happens. After it compiles, the symbol is 1, just like we said it was, but look at the value. That is not the number 1. No, it's not. In fact, where does that value come from? Well, it comes from what's called ASCII, or the American Standard for Character Information Interchange. And here's a table of what ASCII is, where the column in red is the character, for example, the space character, or the exclamation, or the capital letter A, and then next to it are all the values in the HTML entity category, octal values, hexadecimal, and then our counting system, the decimal value. So really pay attention to the decimal column and the character column. Capital A is really, under the hood, the number you and I know is 65. So what's the character 1 then? Underneath the hood, character 1 is really the value 49. In fact, the decimal value 1 refers to this very special start of header character, and that's very different from the character 1. In other words, all characters in a string follow this ASCII and Unicode value. Unicode's another topic for another day. This character 1, as found in a string, is not the number 1 that you and I know, it's just the symbol 1. But under the hood, it's the value 49. And 0, which is, the ones place in the number 10, that is the ASCII value, or the decimal value, I should say, of 48. Let's take what we know now and apply it to this example. If I have a character 1, then when I go to concatenate that into a string, that makes sense. Let's just make the string longer with this one character. Not a problem. And in fact, even when I had a number, an int, and I tried to add that to a string, it took some extra steps behind the scenes. Because this is not actually a string. Instead, implicitly, without our knowledge, it did this. Because in the end, Java does not know how to derive the numeric sum of 49 plus these words. It can't add symbol value to the number 49 and come up with a numeric result like 1028 or something. But Java can turn our number into a string and then concatenate into a larger string. It knows how to do that. So Java will choose to concatenate these two things by converting the int to a string first and then making a larger string. So that's how we go from an int to a string, but that's not parsing. Parsing is the other direction, taking a string and converting it into an int. So when I go back to our previous example that we had, notice that we have the user input, and to you and me, we read this string as the number 10, but the computer doesn't. The computer sees this as the string containing the two characters 1 and 0, which is an interesting idea when you realize that the numeric fact is that this string contains the ints 49 and 48. So when we say something so simple as, here's this int sum, and I want to take the user input and I want to add to it the number 5. You and I might think that's 15. But the computer doesn't know what we mean. And why is that? Well, here's the question. Do we mean 10 plus 5? Or do we mean the string 10 plus the string 5? Or do we mean 49 plus 48 plus 5? Or do we mean 49, and then using some algebraic notation, right? 49 times 48, because they're right next to each other, plus 5. See, there's no clear answer. There's no one way to do this mathematically. The only item that makes any sense at all, the only thing that is not ambiguous to Java is treating them both as strings and concatenating, because that is something that Java can do very easily, and there's only one way to do it. If we look at all the mathematical stuff, there are at least 3 ways to interpret the math to derive a product or a sum. Java does not like ambiguity. It doesn't know what we mean when we say take these characters and add to it the number 5 to derive a numeric sum. However, you and I know what we mean. So it's up to us to tell the computer what we mean by giving explicit instructions. That's where parsing comes in. We want the computer to treat this string as a number, as an int. And the only way to do that is to take the string and parse it. Now you might be tempted, temptation, to cast the string to an int. You might be tempted to take that string and pour it into an int-shaped mold. But again, remember, the string is just a collection of characters where every character is an int under the hood. So how do we take a sequence of ints? Or, for example, what if we had many characters here? How do we take that sequence of ints and pour all those individual ints into one single int that makes sense when you consider that this is the int 49 and this is 48 and this is 57 and so on? How do we make that work? We can't, or rather Java does not know for sure what we mean when we try to pour a string into an int-shaped mold. It can't do it. Instead, it has to parse. Now, some of you might be asking the question, what does it mean to parse? What does it actually mean to parse? Well, basically speaking, parsing means to pull meaning from, or to tear apart to find value and meaning. That's what's happening with this string. It's being pulled apart into its individual characters, and then using some math, it is deriving what the numeric representation really is, or rather, what int literal this string represents. Now that you know what parsing is, now that you know how to parse and why we parse, experiment with this. Feed it different strings. See what happens when you do 10.7 as opposed to 10. Or maybe, instead of doing 10 at all, we do 300 or 300,000. Or maybe we do 3 million or 3 billion. Try 3 billion and see what happens next. You can play around with this all that you want. In fact, you should try the word cat and see what happens when you try to parse cat into a number. Play around with this, see what you discover. But the short story here is, anytime we need to take a string and use it in a mathematical function or to treat it like a number, we have to parse.